Hi everyone, we will continue our Spring Cloud series. In this tutorial, we're going to focus the Cloud SQL service on Google Cloud Platform, and we're going to learn how can we connect our Spring Boot application to Cloud Service instance. But before jumping into directly how we can connect our Spring Boot application to Cloud SQL instance, we should talk about what's the differences between Cloud SQL and on-premise SQL. I already prepared an article about this issue. However, it will be good to mention also the biggest differences between this Cloud SQL service versus on-premises SQL. So imagine you are working in a project with your friends and you don't know how to scale, maintain and manage your own SQL servers. Of course, you need to spend a lot of time for that, learning time. At the same time, you need to find some expert who can understand solidly how to maintain your SQL server. Otherwise, your SQL server can be down at some points when you have a lot of requests. Maybe you might have some security issues because you also need to provide the security for your own SQL servers. But when you switch to Google Cloud SQL servers, you don't have bother yourself those DevOps problems, DevOps things. You just only need to to focus development of your application. You don't need to put effort to maintain scale to your SQL servers because Google Cloud already does everything instead of you. So this is, I guess, the biggest differences between Google Cloud SQL and on-premise SQL servers. Because Google Cloud SQL is fully managed, Google handles mundane tasks like patching, backups, updates, replication, and failover. This reduces operational burden on your team. Of course, you don't need to backup, you don't need to update, replication, anything. The Google Cloud already does everything instead of you. And high availability. You can make your own service high availability across multiple availability zones. However, you need additional infrastructure, but Google Cloud already support this feature in a Cloud SQL service. At the same time, there's automated backups. Of course, you won't have automated backups for your on-premises system. You can maintain it, you can build it, but it takes time and it will consume your energy. I guess there's another thing which is really important: monitoring and optimizations. You can monitor and see the logs of your SQL in Google Cloud. But if you want to monitor your own SQL service, you need additional maybe third-party libraries such as I forgot the name, Prometheus. Yeah, Prometheus. Maybe you need to use Prometheus and other third-party applications. Security, I guess, is the biggest issue in here. You need to support the security for your on-premise system. Of course, all of those things will take time if you don't have any DevOps team. But if you use Google Cloud SQL Server, or which is similar SQL service in the cloud, it will save your energy, it will save your time, it will save a lot of things. What's the advantages of the on-premises SQL service? Of course, in the long term, you might have more advantages because of cost. The cost of the Google Cloud SQL service might be more than on-premises SQL service in the time, but yeah, that's need to be investigated. Because the differences between the horizontal scaling and vertical scaling. Basically, horizontal scaling is adding more nodes, virtual machine into your current machine. But vertical is scaling and adding more hardware resources into your machine, such as CPU, memory, or disk, and etc. So this is the differences between horizontal and vertical scaling. Google Cloud support both, but it support horizontal scalers on read replicas. This is the differences. You can read a lot of things about this in this reference 1 and reference 2 link. There's just too many information and deep information about these two features. So this is a Cloud SQL overview. As you can see, there's a Cloud SQL instance in here, and we have high availability in persistent disk and database or operation system. And we have original virtual machine, static APIs. This is our application, which is our client. So there's logging, monitoring, and other services. cloud support too many services at the same time. So which is really nice to save the time working on DevOps things and especially working on these configurations. Spring Cloud SQL support JDBC and R2DBC connection. You might ask what's the differences between the JDBC and R2DBC connection. JDBC is a blocking database connection, while the R2DBC is a non-blocking reactive database connection. Have you ever heard, I don't know, have you ever heard which reactive programming? Reactive programming basically non-blocking reactive web programming. Reactive web programming basically non-blocking programming, non-blocking process. So how does it work? You will see in the later of this video. When you send requests to API, when you connect to the database, it creates another thread which handles all database processes without blocking your main threads. So this helps to increase performance of your application. This is really important to understand. I'm not going to go into deeply about this reactive programming, but I will attach some links under this video, description of this video, at the same time to this article. You can read this Medium article about reactive web programming, which is really important, but also you will have some ideas what we are doing, what we need to reactive web programming and do to our JDBC database connection. This is all the information that I wanted to give before the start coding. So let's start the coding, let's start implementation. I already created my own Google Cloud projects. You can sign in the Google Cloud, you can apply for €300 or $300, or it depends on your regions, free trial, and you can use it in 90 days. And what you need to do first before everything, you need to create a service account which needs to access your Spring Boot application to Cloud SQL instance. So this is the reason you need to click here, and there is a IAM, and that means you need to go to service accounts page. When you go to service account page, there are already some service accounts I created before this video, and click to create service account, type your service account name, variety spec, YouTube, Cloud SQL. Okay, and click to create and continue. So you need to satisfy a role. Which role would you like to satisfy? Not owner, not that, never ever give a role more than needed. This is really important. What we want to do here, we just want to access our Cloud SQL instance, our database, from our Spring Boot application. So you can go to Google Cloud documentation website, you can read what role can do. We just only need Cloud SQL client because we are the client in here. We want to access to database for some CRUD operation. We don't want to manage to everything in the cloud instance. We can also satisfy Cloud SQL admin, but we don't want it because our application doesn't need to manage the SQL service. It just needs to access the SQL service because of CRUD operation. So that's why I will give Cloud SQL client role. Then I will click continue, and at the end I'll click done, and it created my service account in here. I will click to my service account. I need to download the keys, first generate the keys and then download, because my application will access via these keys. So create new key, it will be JSON. This is all things that I need to do. I already downloaded my key, then we will use it later. So let's go back to the main page, go to search bar and look at Cloud SQL admin. So you will see the Cloud SQL admin API. It's already enabled on my project. You need to enable this project before to create an SQL instance. Okay, I already enabled. If it's not enabled in your project, please enable it first, and then type Cloud SQL and go to this SQL page. When you go to the SQL page, you will see nothing in here because I have already an instance, but we will create another instance together. How can you create an instance? You need to create an instance. The instance means a server. Just imagine it's server, it's your database running, or your SQL server is running. It could be PostgreSQL, MySQL, or SQL server. Okay, click to create instance. What we're gonna use? We're gonna use PostgreSQL. Then choose a PostgreSQL, and then there's enterprise. You don't need to touch anything on here. Just satisfy your instance ID. What's your instance ID? It depends. Berat, YouTube, maybe, right? Your password, or you can click the generate password. That will be really hard. Just give the basic password, Berat123. Then choose closest region in your location. I live in Rotterdam in Netherlands, so it's the closest region for me is Belgium. So you can choose a different region which is more closest to you. Then when you click to create instance, it will create an instance. Not that creating a SQL instance, it's very cost, okay? It's really expensive, so you need to delete everything after doing this video. Don't forget to delete, otherwise you will pay a lot. I have 280 euro, I guess, yesterday, and now I have 240 euro. It consumes 40 euro in one day. That's why don't forget to delete your instance after I finish everything. Okay, so I will go back to my instances, and I already have an instance in here. When you create an instance, you will see your instance in here. I will go to my instance. So I'm waiting. Yes. In the left bar, you will see connections, users, database, and backups. So we need to create users first and then database. So let's create a user. Why do we need to create a user? Because we need how we can access to our database. Of course, via the user, we need a username and user password. So this is the way to access our database. So and also we need to we don't want to give all permissions to one user. Maybe the one user might have just read permission, other user might have the write permission, or both. That's why we need to create a user. It's really straightforward to create a user on Google Cloud. Just click at user account and then fill your username and password. Okay, and just click add, and you will see your user in here. I already created two users, which is Berat and user. Postgres is a default user. You will just only see the Postgres. These are created by me. When you create a user like this, you will see one of the users that you created, and then go to databases. It's really straightforward to create a database. Just click to create a database and type your name, database name here. It's Berat or YouTube. I don't know, whatever you want. Okay. So how can you connect to your database after you created this? Go to Cloud SQL Studio at the left bar side, and you will see your database in here. Just choose one database. I will choose the testDB, and then choose a user that you created, which is Berat for me, and then you enter your password, or not Berat, sorry, user. Then enter your password. Okay, so now we can access our test database in here. This is my database, this is my tables. I have only user table in here. It has two columns, which is ID and username. This is all that you need to do before the starting coding. Okay, so let's go back to coding. Okay, we created the first part. Now let's create a Spring Boot application which has all dependencies. But first, we're gonna create two applications. For which the first one for blocking connection, JDBC. The second one is R2DBC, which is non-blocking database connection, web reactive programming. But let's start the first one. The two of them, which is really straightforward to understand, so that's why it's easy. Oh, no worries. I use IntelliJ IDEA as an IDE, so I don't know how to which IDE do you use in your daily life. But if you use something different else, I don't know how can you create a Spring applications, but also you can create Spring applications via Spring website. Okay, Let's type my application name first. This is just YouTube SQL JDBC. Actually, we're gonna use a data JPA, not JDBC, right? We're gonna use the pure SQL, not pure, sorry, pure SQL. So I will choose a graded Kotlin, then I will click the next one. I will choose Lombok as a dependency, and Spring configuration processor, Spring Web, the data JPA that I'm gonna choose. And then lastly, I will choose PSQL with PostgreSQL driver. This is PostgreSQL driver, and of course, I need to select Google Cloud. Then I will click to create, and then so now I have an application in here. I need to put add another dependency, which is home.google Cloud SQL PostgreSQL socket factory. This is really important to connect our PostgreSQL database server. Okay, so now what we need to do, as you remember, we already installed it, download our service account. So you need to copy paste your service account under this resource folder. And I copy and paste my resource account in here. This is my this is my service account. So I already copy paste under this folder. We're gonna use this service account. So let's go back to application properties. We need to configure everything in here, everything. Okay. The first configuration that we must do this, which is project ID. We need to identify our project ID. How we can retrieve our project ID? It's very straightforward. Go back to your cloud project. Click here. This is your project ID. Okay, this is your project ID. Copy and paste. So yeah, this is your project ID. The second things you need to do, you need to identify, you need to declare your location of service account. This is your service account, this is the location of service account. So let's copy paste this reference from resource and file, then yeah, this is my service account. Now we need to define our database resource, the database credentials. First things that I should define data source username. The data source username user. You need to use your user that you created a couple of minutes ago with me. I have user, I have Berat. I will prefer either Berat or user, but now I prefer the user. And password is user123. My dialect is PostgreSQL dialect, and my instance connection. So this is an important. How can you know your instance connection? It's pretty basic, by the way. Go back to your cloud UI, go back to all instances, click your instance, then click the overview. So you will see your connection name in here. This is your connection name. Copy your connection name, go back to Spring application and paste in here. This is all that you need to do. Last things, you need to identify which database you will use throughout the application lifecycle. Okay, so this is a test DB, which is I created. Of course, you already created a DB. You need to identify your database name in here. Lastly, I will use the Spring DLL Auto and SQL True. Spring DLL Auto is important. Why it's important? Because I want to create my instances in the compile time. Okay, so the other code, this is all that I need to do. Let's run my application. As you can see, oh, something happened. Oh, something used my application in the background. Let's find it first. Okay, my 8080 port was used by different application. I don't know which application. That's why I will change my port 8090. Okay, So I will rerun my application again. So as you can see in here, Tomcat started at 8090, so there is no any issue. I already connect my database without any problem. Let's preview it. Okay, now normally I'm not going to talk about how can we create an entity, how can we create a repository and a controller in Spring Boot application, because these, I assume you already know those things. That's why I will copy paste these codes from another application. So I will copy and paste. Okay, now you will see there's a user. This is my entity, and there is a controller. Oh, yeah, I need to change this controller. Okay. And repository. Yeah. I also need to update my repository. I extended my user repository from the JPR repository because it will create some SQL commands in the background and insert my data in my object to SQL. So I have a user controller in here. This user controller has two different methods, which is a compatible feature and the normal one. I put some logs in here to see the differences between our JDBC and GDBC, because when you will see what the differences is after I run this application. Let's rerun it again, and then before the rerun, let's go back to our UI. So click the Cloud SQL Studio and click in here, insert into, let's insert the data into our users table, users, ID and username. So values is and username is Parat YouTube. Okay, run it. And statement executed successfully. Go back to application. So it's running already. Go back to user controller, click in here, generate request in HTTP client. So rerun this client. So you retrieve nothing. Why? That's actually very strange. You didn't get anything. So you should get some things, but you didn't get it. So this is a question. This is why we couldn't receive the data from here. What database we use? We use this one. Users we have. Okay, let's run another one. Let's user size 2. That's nice. We already received it. Okay. We do get it. We do get it. Probably it doesn't show us. Why it doesn't show us? I don't know. It shows up, but yeah, probably should be bigger. That's why it doesn't show us. So we can retrieve our data from our database. So we already connect to our Cloud SQL service. It's really straightforward to connect that. So what we did, we just put our service account under these resource folders, and we had a couple of configuration in the application properties, which are my username, user password, dialect, connection name, and test DB. At the same time, project ID and location of my service account. This is all you need to connect to your Cloud SQL. So let's go back to these logs, because the logs are really important. Console. As you can see at the end, we have thread name HTTP NIO 8090 exec1, beginning of the process in here, beginning of the process, and we have another log which is at the end of the process, which is the same thread name. right? So which means it's blocking the threads. It waits until the database operation completed. So we are blocking the threads, and which means it reduces performance of the application. We have another the controller, the HTTP method in here, which is not HTTP method, API in here, which use compatible feature. Compatible feature is a way to make the asynchronous. But the differences between this and this one, when you run the compatible feature, it still block your main threads, but it just run the database operations in the new threads. So let's see it. Click the generate request HTTP. Click in here. We already received the data. Look at here. Fork join pool common worker. What it does, it take a thread from your pool. It doesn't create a new thread. Take a thread from your pool. So this is the differences between compatible feature and the normal one. Of course, this is still blocking. So that's why we need to use reactive web programming with R2DBC. So Cloud SQL also support R2DBC. Spring Cloud support R2DBC, which is really nice feature that we should use it. How can we use it? Because we need to create a new project for that. Let's create it. New project. GitHub SQL R2DBC. R2DBC. Sorry. Yeah. I will choose the create a Kotlin. Next, I will choose Lombok, configuration processor, Spring Reactive Web, not Web, and then PSQL, PostgreSQL. There's a PostgreSQL driver in here. Cloud, Google Cloud. I will choose Google, and then lastly R2, the JPL, but which JPL I'm gonna choose, that's a JPL, but not this one. I will choose R2DBC. Okay, this is all I need to choose. I create a new window. So this is my R2DBC project. What I need to do, by the way, I will do exactly the same thing, just configuration will be different and repository will be different. So first, let's copy our service account to our new project, which is R2DBC project, under the same folder, same location. So copy it here and paste here. Let's go back to our application properties. I will copy paste everything from here. Come on. And here. Okay. So let's delete this. We need to change something. We're not going to use the data source. We use R2DBC username and R2DBC password. So this will be exactly the same. This will be exactly the same, but we also need to change something, which is URL. So we also need to add R2DBC URL. This is R2DBC GCP, which is Google Cloud, PostgreSQL. Our connection name is the same in here. By the way, no differences. No, it's different. It should be like this. This is wrong. I copy paste my project ID. Actually, this is my project ID. You need to copy paste your project ID here. My region, which is Europe West 1, my user, actually this is not my user, this is my instance name, instance ID, it's user. Let's go. This is this is my instance ID, all instances. This is my instance ID. Okay, this is instance ID. And database name. This is all you need to do. I will change the port 1891. So this is all I need to do. I don't need anything else more. Let's go back to coding. That will be a little bit different. I will copy paste all codes from somewhere else. And this is all codes that I need to do. Sorry, that's wrong copy paste. Sorry, I need to delete. Okay. So by the way, yeah, I forgot that one. We need to add another dependency, which is really important dependency. This is again Spring Class Starter JDBC repository. This one, yes, this is, we need to add this dependency. Okay, let's rerun the Gradle and let's go back to my application. This is a user stable user controller, so I need to change the imports. So yes, this one changed the import in here. As you can see, this is the biggest difference between our JDBC and .jpl. Our JDBC uses its own repository, our JDBC repository. It takes which entity that it's gonna work and identity type of the entity which is gonna work. Okay, and when you go back to your JDBC, your user repository uses JPL repository. Actually, this is not JDBC, this is data JPL, but it uses JPL repository. Your application use our JDBC application use our JDBC repository. This is also one of the tiny differences between those. Okay, let's run your application with debugging mode and just make sure everything is right. So net is started on port 1891, which is really nice. Let's go back to user controller, generate an HTTP request, click in here. So as you can see, you retrieve data from your SQL database. I mean your Cloud SQL client, Cloud SQL service. So go back to logging. This is the biggest differences between non-blocking and blocking. As you can see in here, it start HTTP. Now you have 2 threads, and then it didn't block the main thread. It continued with different threads by creating a different thread because it was waiting response from the database, and then when it got all response, it continued with another thread at the end. So this is the biggest differences between our JDBC and JDBC. It's a non-blocking. When we don't block the threads, we increase the performance of our application, because in that way we can retrieve more API requests at the same time. And that's why reactive web programming are really important gateways, especially in the gateways. Imagine you have a backend for front end or API gateway in front of your all services. Most of the time, these gateways and backend or front ends waits the response of other services. But in that case, usually the companies and the architects would prefer to use non-blocking connection, which are reactive web programming. So this is an importance. In here we use Flex. This is coming from Reactor Core. Okay. So this is not the main issue of this video, but we will talk about what's the differences exactly, what's the web programming, what's the reactive web programming is, and what's the normal web programming is. We can talk about it later, but I will attach a very good articles on the description of this video. You can see it. You should read it definitely. You will understand the concept of reactive web programming. It is really, really important, and which is really useful. This is all that I want to talk about throughout this video. See you later. Thanks for listening and watching.